Hello, guys. Welcome to the Extraordinary. Another brief one today. We're going to be looking at sets. A set is an unordered collection with no duplicate elements. Basic uses include membership testing and eliminating duplicate entries. Set objects also support mathematical operations like union, intersection, difference, and symmetric difference. Curly braces or the set function can be used to create sets. Note, to create an empty set, you have to use the set function, not an empty curly brace. The latter creates an empty dictionary, a data structure that we'll discuss in the next episode. Let's have a look at some examples. So we'll create a new file here called example1.py, and in here we're going to define a set. So we'll say basket, apples, orange, apple, pear, orange, banana, and then we can print the basket. When we run this, we see that we get apple, banana, pear, and orange. There are no duplicates in the set that was created. Now we can check if there is an element in the set by using the in keyword. So for example, print orange in basket, and what do we have? We have true. That's because there is an orange in basket. If we check if crabgrass is in basket, what do we get? We get false because there is no crabgrass in the set, the basket set. We can also perform other operations, some set operations, mathematical set operations on a set. So to show that, let's create another set. Let's assign a set of abracadabra, and B set of alakazam. Now if we print A, we get all its values. To avoid confusion, let's comment these ones out first and clear this. We get all the values of A. Let's print A minus B. So say A minus B is equal to A minus B. And what do we get? So we see A minus B is equal to RBD. What that means is that all the values of A, or rather all the values of B, are taken out of A, and what is left is printed out. So A is taken out, L, there is no L. Hold on, let's see. there is no L in A, so that is not going to show up, because we are displaying A, all the values of A, but we are going to first remove the values that are in B. So A is in B, so that will be taken off. B is not in B, it's not in the set B, so that is still here. R is not in the set B, so that is still here as well. What else? C is in set B, so that is taken out. D is not in set B, so that is still here. Every other thing is here, is in set B, and so that will be taken out. But remember, first of all, every duplicate would be taken out first. So what we would have is A, B, R, C, D, and then we will now remove everything that is in A. So if this set is, let me see, hold on, let me print B so that we get a better understanding of this. B is equal to okay, so we have our values. The set A contains B, C, R, A, D, and the set B contains C, A, L, Z, M. So A minus B will give us the values of A after we have taken out the values of B from it, and that is going to be BRD, because C is in set B, so that will be taken out. A is in set A and is in set B, so that will be taken out. So what we are left with is BRD, as we can see here. Let's move to the next example. We check for A or B is equal to A or B. So this is going to give us letters that are in A or B or both. So let's say that. So we get A, B, Z, D, B, R, C, A, M, L. This is giving us more or less like a union of the two sets. And if we want an intersection instead, we can do that with A and B. It's equal to A and B. What do we get? This is going to give us only the letters that are in both A and B. So let's run that. And here we have it, A and C. These are the only letters that are both in A and are also in B. That's the intersection between the two. And last but not least, we can do A accent B. So A accent B, and this would give us letters that are in A or B but not both. So this is going to be a union of the two, more like an exclusive union of the two, right? So let's say that. Yes, so this gives us MLRZDB. Let me add an equal to sign here. Another thing that we can do is just like list comprehensions, just like list, we can create comprehensions for sets as well. So let's take a new example. Example 2. So here we'll say A is equal to x for x in abracadabra if x not in ABC. Notice that in this case we are using curly braces instead of square brackets. This is what makes it a set comprehension rather than a list comprehension. Now let's see what we get when we print A. We get only R and D, because this if not in ABC is going to remove all items that are not R and D. First of all, we are going to remove every duplicate, and then we're going to remove A, B, and C as well. So what will be left will be R and D. And that's it for sets. Like I said earlier, we are going to be looking at dictionaries in the next episode. If you enjoyed the content, please like, share, and subscribe, and I'll see you in the next one. Bye.